Hi everybody. For our video today, we're going to talk about linear functions. So make sure you go ahead and give your video a title, 3.2 to 3.3 video notes. And we are going to first talk about how a linear function has a key feature, and that key feature is that it has a constant rate of change. All right, and you may have heard a word that means this, or a similar word. Constant rate of change means slope. All right, so a linear function has a constant slope. And when we make a graph of a linear function, it makes a straight line, hence linear, like line, okay? So on this slide here, we've got a couple examples of, here's a linear function. Notice it makes a straight line. And here is what we call a nonlinear function because it does not make a straight line. And then in a table here. So if I give you a table, the way to figure out if it's a linear function is to check to see if it does have a constant rate of change. So we look at how the x values are changing, and the x values from -2 to -1 went up 1. From -1 to 0 went up 1. And for each of these, the x values keep going up by 1. That's constant. It's not changing. All right. But in order for this to be linear, we need the y values to also go up by the same amount every time. So when we look at the y values, I start at -5 and it goes up to -2. That was a change of +3. Then from -2 to 1, that's also a change of +3. 1 to 4 is +3. 4 to 7 is +3. So, because that has a constant rate of change, we know that this is an example of a linear function. Okay, linear, because it goes up the same amount every time. I could also make a graph of this. I'm going to graph these 5 points on my grid to the right here. So to graph -2, -5, I'm going to go left 2, and I'm going to go down 5. 2, 3, 4, 5. And so I'll put a point right there. Then I'll do the same here. We'll go left 1, down 2. And there's my second point. Then don't go anywhere, left or right, but up 1 is 0, 1. And then 1, 4. And then I'm going to run out of room here, but 2, 7 would be right about there. And you'll notice that those points line up in a straight line, hence a linear function. Okay, so now we're going to move on to something called function notation. All right, so when we have a function, you guys are probably used to seeing an equation that's written like y equals 2x plus 7, something like that. Okay, well, when we talk about functions, another way we can write them that can be kind of useful is to use what's called function notation. And so we have this piece here, and you say that f of x. It's really saying that this is a function of x, meaning x is the variable in my function. Okay, and so that f of x, it replaces y. So instead of y equals 3x minus 7, we're going to have f of x equals 3x minus 7. Okay, it's just a notation that mathematicians like to use because it tells me what the variable is, and if I'm going to then plug in a number for x, I replace that x right there, the f of x, I replace it with a number. And you see that down below here in number 1. Okay, so a problem like this says f of 9. All right, up above, the f tells me that I'm going to be using this function, and 9 tells me I'm going to plug in plug in 9 for x and evaluate. So the way we do this problem is we say f of 9 equals 3 times 9 minus 7. And then I just evaluate. So then I get it equals 27 minus 7, 27 minus 7, which equals 20. So my final answer is that f of 9 equals 20. And what this really means is that when you plug in 9 for x, you get 20. Okay, so we could do this again with g of negative 2. That means I'm going to plug in negative 2 in for x in the function g. Okay, when you plug in numbers, you should always use parentheses. So when I do this, I'm going to say g of negative 2 equals parenthesis negative 2 squared. Okay, because in this function it's saying x is being squared, and x is the number negative 2 now. So I'm saying negative 2 is being squared, and then I have to continue this and say minus 4 parentheses negative 2. So now to evaluate this, I say negative 2 squared is positive 4, because negative 2 times negative 2 is positive 4. And then minus 4 times negative 2 becomes plus 8. And 4 plus 8 is 12. So my answer here is that g of negative 2 equals 12. We'll try a few more on the next page. Okay, so here's another example. So again, when we have this notation, the inside of the parentheses is telling me what am I replacing x with. So this is saying take the function f and replace x with a plus b. All right, this time it's a little different because it's not a number, but we can still do it. So we say f of a plus b equals 3 parentheses, because I'm plugging something in, and now I replace x with a plus b minus 7. So then to simplify this, I should distribute the 3, so I get 3a plus 3b minus 7. And I'm done because I don't have any like terms to combine. So that's what f of a plus b equals. Number 4 has these little bracket things here. Okay, in this problem, the context here, those brackets are just another set of parentheses. Okay, that's all it means. So this just means 2 times g of 5. So all I'm going to do to solve this is figure out what g of 5 is and then multiply that answer by 2. So I'll go 2, and if you like better, you can just make them big parentheses. 2 times, and now I'm going to plug in 5 for g. So I'm going to say parenthesis 5 squared minus 4 parenthesis 5. Notice that's just plugging in 5 into x squared minus 4x. All right, and now we'll do some order of operations here. That's 2 times 5 squared is 25 minus 4 times 5 is 20. That's 2 times 5, which is 10. Notice this is 25 minus 20. I can do that and get 5. Don't distribute here because you can simplify the inside of the parentheses to just get 5. All right, and then the last problem on this page just says take f of 7 and add it to g of 6. So I'm just going to evaluate both of these and add them together. So f of 7 means I'm going to plug 7 into f. So that's 3 times 7 minus 7 plus, and then I'll do g of 6. 6 squared minus 4 times 6. So for the f part, I plugged into f of x, and for the g part, I plugged into g of x. All right, and then let's see what these equal. So this equals 3 times 7 is 21 minus 7 plus, and then 6 squared is 36 minus 24. And that's going to equal 21 minus 7 is 14 plus 36 minus 24 is 12, and 14 plus 12 equals 26. And so there's my answer there. And lastly, in this video, we're going to talk about using a function to then make a graph of it by making a table. Okay, now I know some of you have done something like slope-intercept before, right? And we'll get to that in very soon. But for right now, we're going to just graph this by making a table. So when you do that, we're going to pick 5 x values. And 90% of the time, the x values that we're going to pick are -2, -1, 0, 1, and 2. Because that gives us a good like center 5 points. It's centered at 0. We do 2 to the left of 0 and 2 to the right of 0 to make this graph. Okay, and so to get the y values, I'm just going to plug in those x values into my function. So what I'm really doing here is f of -2. And so just like we did before, I'll plug in -2. So -2 parentheses -2 plus 1. And if I do that, that's 4 plus 1 is 5. And so I'm going to do that over and over again here. If you want to pause the video and try the rest of these on your own, I'm going to get these up here real quick. Okay, so as I fill out the rest of these, I got 5, 3, 1, -1, -3. And then I'm going to graph those as points on my graph. So then I go -2 to the left and 5 up for my first point. 1 to the left and 3 up. 0 to the left and 1 up. 1 to the right and 1 down. And finally 2 to the right and 3 down. Now in this graph, I was given a function, f of x equals -2x plus 1. So when I do this, I'm going to connect the points. And so I draw the line because I picked 5 x values to plug in, but really I could have picked any x value. We say that the domain is all real numbers, -infinity to infinity. Okay, so thank you for watching, and that's all.